Hello and welcome guys. Now in this video let's understand how polynomial regression is different from simple linear regression. So polynomial regression and linear regression are both type of regression analysis only. They both use for modeling purpose, and the relationship between a dependent variable and one or more independent variable, that is what regression tell us, right? And linear regression and polynomial regression, they are both a type of. Okay, so what is the key difference? Why we use polynomial regression over linear regression? So the key difference is, first of all, linearity. Okay, so in linear regression it assumes a linear relationship between independent and dependent variable, whereas in polynomial regression it allow for a more flexible non-linear relationship by introducing polynomial term. So we'll discuss about polynomial term as well. Then other key difference is equation complexity. Now linear regression has a simple equation with linear term that you can see here, whereas for polynomial regression has more complex equation. Not more complex, but just we are adding one additional term for each power of x up to the chosen degree. Okay, so the square that you see is chosen degree. Now fit to data. So linear regression fit a straight line to the data point, whereas polynomial regression can fit curves or higher order pattern to the data that you can see here. Okay, the curve line and the straight line. Then we have another key difference, that is linear regression has a degree of 1. Okay, whereas in polynomial regression it allow you to select as much degree as you want, like n, whatever number you want to decide. So based on the complexity of underlying relationship, higher degree can capture more in intricate pattern, or you can say very complex pattern, or uncapturable pattern for for fitting the perfect model. Okay, and just remember, sometime higher degree can also may risk for overfitting, so make sure you just remember it. Now what is the main difference between them? So main difference between them lies in the form of regression equation that you see here. Okay, so in linear regression the formula is y equal to b0 plus b1 into x. Okay, whereas y is the dependent variable, x is the independent variable, b naught is the y-intercept, b1 is the slope of regression line. Whereas in polynomial regression the formula is b naught plus b1 into x plus b2 into x square plus dot 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 bn into x to the power n. Now here also y is dependent variable, x is independent variable, b naught b1 or all are coefficient of polynomial function, and n is the degree of polynomial, so n is new here. Okay, so as you can see, the polynomial regression equation is more complex than the linear regression equation. So this is because it include additional term that allow it to model non linear relationship between the dependent and independent variable. So the line that you see here, the curve, is a non-linear relationship, and the line that you see here in the simple linear regression chart is the simplest uh, linear relationship. This is just a straight line. Okay, now for example, if the relationship between dependent variable and independent variable is quadratic, then the polynomial regression equation of degree 2, which is n equal to 2, can be used for modeling it. So if the relationship is cubic, then a polynomial regression equation of degree 3, that is n equal to 3, can be used to model it, and so on. So it is important to note that polynomial regression are more complex than the linear regression. Therefore obviously it will be prone to overfitting. So this means that it is important to carefully choose the degree of polynomial and to evaluate the model on the held out test set to ensure that the it generalize well on new data. Okay, so that's the main difference. So in summary, I just wanted to highlight one point. So while a linear regression model linear relationship between a straight line, while polynomial regression accommodate more complex non-linear relationship by introducing polynomial term with different power of the independent variable. So the choice of these two algorithm depend on nature of the data and underlying relationship that you want to be model. Okay, so that's all. In polynomial regression, that's all. Now let's move to the coding part, and we'll see how we model it basically. So it will be similar as linear regression. The only difference will be we will be adding a square term, or you can say degree term, in the polynomial regression. So let's see you in the next video.